Hello everybody, welcome to Virtual School Physics is Fun. We are continuing with Pulley system part 2. Okay, now the second case is the pulley is held on the edge of a table and the rope is holding up to two loads. One is hanging freely, the other one is placed on the table. Let's say the table is smooth. Okay, so what are the forces acting on this system? So number one, of course, this load that is placed on the table, it will have its weight, right? W1 acting downwards. And this smaller load will have its weight acting downwards too, and we name it as W2. So when this system is let go, all right, it will move. So the smaller mass, the smaller load will move downwards. The bigger ones that is placed on the table will be dragged, will be pulled to the right by this rope, because they are connected to the same rope. So both of these loads will be moving with the same acceleration A, but in this one downwards. From the diagram here, it shows that the smaller mass is moving downwards, but the bigger mass is moving to the right. So in order to understand this better, I straighten the rope. I stretch this rope. Okay, I stretch this rope, and when you stretch the rope, you can see very clearly that the whole system is actually moving to the right. Yeah, it is moving to the right. And the weight of this smaller mass, W2, is in the same direction as the acceleration A, so W2. But the W1 is not in the same direction. It is not in the same direction. So W1 is supported by the table, so it does not play any role in pulling the system to the right. Okay, so this whole system, W1 is not involved. So since the table is smooth, there is no friction. So the frictional force will be the one acting against the motion. Yeah. So the frictional force will be acting to the left. But since it is smooth, there's no friction. So there is no force that is acting to the left. Okay. By using Newton's second law, F equals to ma, so we see that the net force is to the right, same as our A. Yeah? So the net force is equals to W2 only. Yeah? W2 minus 0. So equals to ma. The m is the mass of that moves with acceleration A. So of course, both of these masses are moving. Therefore, it's capital M plus small m. All right. So the net force will be W2 equals to M capital M plus the small m bracket the acceleration. Okay. So the weight of the M is supported by the table, so it does not contribute any force to the pulling of the system downwards. Yeah? Okay, let's look at concrete example. So I have this smooth pulley held up one load that is 5 kg, whereas the one that is on the table is 12 kg. So this smaller mass, will move downwards, and the mass that is on the table will be pulled to the right. So we straighten the rope. Okay, so the net force is to the right, and net force is equals to the weight of this small mass, and it is smooth, so there is no force acting to the left, so it's 0. Therefore, net force is 50 minus 0. Okay, so is W is our 50. Yeah, the weight that is pulling it down. Yeah, 50 equals to the masses of the two loads times the A. So the weight of the small mass is 50. The mass of both the loads are 12 plus 5. So 12 plus 5 equals to 17. So from here, we calculate our acceleration. Acceleration will be equals to 2.94 meter per second square. Okay. Now, if we want to calculate the tension of the rope, so again, we cannot calculate tension of the rope if we look at this system as one whole system. We have to split it into two parts. Yeah. So let's say we take the part of the 5 kg load, this one only. Okay, so we have F equals to MA. Now, by looking at only this side, this system only, so the net force is downwards. So W is same as the net force. So W is 50 Newton is positive, but the tension of the rope, which is opposite direction, so it is negative, equals to MA. So the mass is only 5. Don't plus the 12 kg. Only 5 because we are only looking at the 5 kg load. So times with the acceleration that we have calculated just now. So through this, we can calculate our tension of the rope. So you can calculate the tension by looking at this system too. So you do the same way. Okay. All right. That is by looking at the 12 kg system only. So this 12 kg system is moving to the right, isn't it? So the net force is to the right, which is the same direction as the tension. Okay, same direction as the tension, and the table is smooth, so there is no force acting backwards to the left. So the net force is only T minus 0 equals to MA. M is the mass of the load here, so 12 kg times the A just now. So with this, we still get the same answer as if we take this system, right? So you can take any of these two sides to calculate the tension. All right, let's look at this case where the table is not smooth, but it has got friction. And let's say the friction is 10 Newton. So how does this whole system change? Right? Okay, so we stretch the rope again. So now the net force is also again still to the right, isn't it? Still moving to the right. Okay, when we stretch out, it's moving to the right. So the 50 Newton is the same direction, so it is positive. But the friction is to the left, so it is negative. Yeah, opposite direction. Okay, so now F equals to MA. So the net force will be our W, this W minus the friction, right? Minus the friction. So 50 minus 10 plus equals to the mass, the mass of the 2. So 12 plus 5 times the A. So from here we get A equals to 2.35, yeah, which is lower than just now when the table was smooth. Obvious, isn't it? When it is rough, so obviously the frictional force will not allow the object to move equally fast, right? So it will accelerate with a lower rate. Now tension, what about tension? So if we look at this side, same way, it is moving downwards. So W is same direction, so 50 minus T, tension, which is opposite direction, equals to 5 times your acceleration. So now we get our tension 38.25. Okay, so the tension is 38.25. What if we take this side? Same way, yeah, we take the side of 12 kg load, so F net equals MA. So now the system is moving to the right, so F net is to the right, F net and tension is the same direction, so it's positive, T is positive, but friction is opposite direction, so minus friction equals to mass times acceleration. Okay, so from here T is again the same answer 38.25. Yeah, so same answer. So it does not matter whether we take this side to calculate the tension or the other side, both will give the same answer. Okay, clear? All right, so do try a lot of question regarding this Pulley system to get yourself familiarized. If you are still not sure, look back, view back this video again until you fully understand. Okay, that's all. Thank you. Do watch out for other videos coming up. Bye.